So let's go ahead and get started with our first method to solve this problem. To start off, let's go over the math topics which we're going to use in the first method. So we have properties of sets, such as cardinality, subsets, definitions of sets, and etc. We have principles of stars and bars. So an example of that is in the form nk, also known as n choose k. So that's an example of 16 minus 2s choose s. And we'll see something similar in our solution. Sigma notation form and rules. So that's something like sigma of 8 s equals 1 of the function x squared. So that means that you evaluate this function for all the values of s ranging from 1 to 8. And you add them. So that would be x squared plus, or 1, when x is 1, plus 2 to the power of 2, that's 4, plus 3 to the power of 2, that's 9, and so on. So that's sigma notation. Now, basic probability, such as reading general problems and finding the total number of outcomes we have. We have the binomial coefficient theorem, which is n choose k, is basically the same as n factorial divided by k factorial times n minus k factorials. We have combination, it's pretty much almost the same thing. Basic arithmetic, such as addition, subtraction, because those are key. And also factorials. 16 people are sitting around a circular table, each holding a fair coin. All 16 people flip their coins, and those who flip heads stand, and those who flip tails remain seated. What is the probability that no two adjacent people will stand? So let's start off by making some observations. So the question is asking for the number of subsets, okay, and we can call that A. So the subsets in the group range from 0 to 15, because in a set you always want to start with 0. Okay, so in this you have 16 terms. So in our case it's 16 people. So that's the set that we have. So therefore, from that given set, we can figure out that the sigma notation we can derive from this is 15 minus s and s minus 1. Okay, so we can use factorials to solve this. Like, these are the possible outcomes for subset A. So it's a probability. So 15 minus s and s minus 1. Okay, so that's the first observation. The next observation is that we know our cardinality is 8 because 16 divided by 2 is 8. So that's the max number of people that can be standing without two adjacent people standing. Because if you have 9 people standing, there must be 2 people standing next to each other. So you can't have that. So since 8 is half of 16, you can have alternate pieces. So to start solving this, we would have 2 distinct cases. So the first one is when the possibilities in our case range from 1 to 8. Okay, not 0 to 8, but 1 to 8. So there's 1 to 8 people standing. So that's when we have 15 minus s and s minus 1, because we start from the value of 1. So this would eventually become into a factorial, which we'll solve. And the second case is when we have 0 people standing. Okay, so 0 is not an element of A. Okay, so then that's when we have 0, 1, 2, 3, 4, 5, 6, 7, 8, all in the same set. So that yields 16 minus s and s. Okay, so again, this will be transformed into a factorial as well. And this is s because we have a 0. So let's start off by solving this, expanding this side of the equation to solve. So to expand this side of the equation, we would want to use sigma notation, so it would be 15 minus 1, choose 0, plus 15 minus 2, choose 1, plus 15 minus 3, choose 2, plus 15 minus 4, choose 3, plus 15 minus 5, choose 4, plus 15 minus 6, choose 5, plus 15 minus 7, choose 6, plus 15 minus 8, choose 7. Okay, so here we've used sigma notation formula as well as the factorial formula right here. So we can use the fact that n choose k is equal to n factorial divided by k factorial times n minus k factorial. And here we could simplify this. So for example, this is 14 choose 0. So this is the same thing as 14 factorial divided by 0 factorial times 14 factorial. So that's equal to 1. And 15 minus 2, choose 1, is equal to 13, choose 1. And that's equal to 13 factorial divided by 1 factorial times 12 factorial. And that's equal to 13. And so on, as we get all the way to the end, and we evaluate these factorials. And the way we go from here to here is using this formula. Okay, so then for a total, on the left side, we get a total of 610. So now we're going to solve the right side of this equation. So we would do the same for the right side again. So we have 16 minus 0, choose 0. 16 minus 1, choose 1. 16 minus 2, choose 2. 16 minus 3, choose 3. 16 minus 4, choose 4. 16 minus 5, choose 5. 16 minus 6, choose 6. 16 minus 7, choose 7. 16 minus 8, choose 8. And they're all added with each other because that's the definition of sigma notation. Okay, so that simplifies to, again, we would use the same fact, the factorial. So n choose k is equal to n factorial divided by k factorial times n minus k factorial. And we would do the following. So 16 minus 0, choose 0 is basically 16 factorial divided by 0 factorial, 16 factorial. And keep in mind 0 factorial is always 1. And same here. This is 15 because 16 minus 1, is 15. So that's 15, choose 1. So that's why it's 15 factorial divided by 1 factorial times 14 factorial. And you would do the same for all of these. And here's what we get. And we can either use a calculator or we can do it by hand to find the exact values of this. Personally, it's easier to do it anyway, actually. Because, for example, if you had 15 factorial divided by 1 factorial times 14 factorial, that's 15 times 14 factorial divided by 1 factorial times 14 factorial. So the 14s can cancel out. So 15 divided by a 1 factorial is just a 15 factorial divided by 1. So that's equal to 15 factorial. Okay, so that's what we do for all of this. Well, it's not 15 factorial, actually. It's just 15. Okay, so it's not factorial. It's just 15, which is what we got here. So we do the same for all of those, and we get 1,597. So keep in mind that we would have to add up what we got for the first side, 610, and 1,597. So that's equal to 2,207 possibilities for A. So there's 2,207 possibilities that can occur. But we have one more step as well. And that step is to find the number of possibilities with the tails. So if each coin can have two flips, and there are 16 people, 2 to the power of 16, which is and 2 to the power of 16 is equal to 65,536. So the solution for this question is a probability of 2,207 divided by 65,536. So that's the probability for the answer for the question. And we're done.